All right, so we have finished with section 4.4. This is going to be the start of 4.5. We're going to do a little bit of this and get to where we need to be, and then I'll get you guys the review for the quiz, and we should hopefully have some time at the end to work on that, ask questions, and all that stuff, because we have a quiz coming up on Friday, and I know it's that find all solutions, and there's a lot of stuff on there. So I want to give us a little bit of time to work on that, ask questions on the homework, things like that, but also we need to keep moving. So we're going to do a chunk of this, and then we'll have some time to work, hopefully. Okay? That's kind of the plan for the day. So we're going to be getting into rational functions, which you have seen before. You did these in Algebra 2, but it's been a minute. So this is when we have our fraction-y guys, where it looks like usually it's a quadratic over a quadratic, or a quadratic over a linear, or it could be a linear over a quadratic, that kind of stuff. So it's the fractions that have polynomials in each one. So our first thing that we need to do is to figure out where we find our domain for these. So the only problem we get on rational functions is when our denominator equals what? Where do we have problems in denominators? 0. So our domain, for the most part, is going to be all real numbers, just except where our denominator equals 0. So what we're going to do is make the screen blink. I'm going to give you a function, and we're going to figure out where our denominator equals 0. So our first job here is to find our domain. So we have f of x equals 4x squared plus 3x minus 7 over x squared plus 8x plus 15. Oh, let me change the view. So how can I figure out where our denominator is going to equal 0? Yeah. We're going to take this guy and factor it. Where each factor equals 0 is where we have problems. David, you might want to have a seat, dude. And write things down. We're going to factor this. So do that. Factor that. What do we get when we factor this? Yeah. Our factored form, we get x plus 5 and x plus 3. So our factors are, negative 5 and negative 3. So the only places we have problems are when x equals negative 5 and x equals negative 3. So our domain is everything except those. So when we write that in our interval notation, our domain, we're doing this in our interval notation, so it's everything from negative infinity to positive infinity except for those. So we're going to go from negative infinity up to negative 5, not included. And we put our union from negative 5 to negative 3, parentheses, and from negative 3 to infinity. So that's how we can say it is everything from negative infinity to positive infinity except for those two values. We've got to jump over those two. Okay? So our domain comes from where our denominator equals 0. That's how we find that. Questions on that bit? Okay. Because we're going to get to the point where we're graphing these functions. Like, I think tomorrow we're going to graph some of them. So we have a lot of pieces that we're going to need to be able to put together an image of what these are going to look like. So another thing that's going to help us is if we can find our intercepts. So we're going to find x-intercepts. We're going to find y-intercepts. And so I've got rules up here for both of them. Our x-intercepts are going to be when our numerator equals 0 or when y equals 0. Our x-intercepts happen when y equals 0. That's what the definition of an x-intercept is. Because we write our x-intercepts, that's our x, comma, 0. Whatever that is, that's our x-intercept. So when our y is 0. Our y-intercepts is the other direction. It's 0 in place of the x's. So this would be our 0, comma, y, whatever that is for our y-intercept. And what we're going to find out when we do our zeros in places of our x's, it winds up just being the constants that we have going on there. But we'll see what that looks like here in just a second. So what we're going to do is we're going to find our intercepts for both of these different ways we're going to see rational functions written. Because this is two different forms for rational equations. So the left one is where it looks like a quadratic over a quadratic. So what we're going to do is we're going to find where our numerator equals 0. Our x-intercepts are where we have our numerator equals 0. Because if I have a 0 on top, this whole fraction equals 0, and it's when that's 0. So we need to know, when does that guy equal 0? I'm just going to write it down. So we're looking for when does x squared minus 2x minus 8 equals 0. That's what we're trying to find for our x-intercepts. Well, a positive 4 and a negative 2 when we're like putting it in factored form? Factored form. Put it in factored form. Thank you. This is, at some point, we're going to get to the point where we have our discontinuities and we need to simplify things out. So I know that you guys can probably make the jump in your head, but it's a good habit to be in to put it in our factored form because we are going to have to simplify these at some point. So then we're going to have our x minus 4 and our x plus 2. So our x-intercepts are happening where? Positive 4, 0, and negative 2, 0. That's when it's really helpful to write it down in your factored form so you can look at it. It makes it really a lot more clear so that we have our signs correct because there's a lot of sign changes involved in that. So for x-intercepts, we're looking for when our numerator equals 0. Our domain we get from where our denominator equals 0, because that's where we can't have that happen. So to find our y-intercepts, what we're going to do is we're going to substitute in 0 for every single x in the whole function. So f of 0, whole thing. So we're going to have our 0 squared minus 2 times 0 plus 8 over 0 squared plus 2 times 0 minus 15. It is minus 8. Sorry, I'm reading from an incredibly harsh angle over here, and it's really hard to see. There we go. Minus 8. I'm just reading from like the side of the screen right here. Substituting in 0 to our functions.
So negative 8.
So all of those zeros kind of cancel out. So I got 0 minus 8. So we get, negative 8. And 0 plus 0 minus 15. So where is our y-intercept going to be? 8/15. Yeah. So we have a point at 0, 8/15, which is not pleasant, but doable. It's almost a half. Or no, a little bit over a half. Because 8/16 would be a half. So our x-intercepts are at 4 and negative 2, and this guy is our y-intercept, just so we're labeled. All right. So the one on the right is not in our p of x over q of x form. So it's in a different form. This is our transformation form. So in order to use our ratios and kinds of things, what we're going to do is we're going to simplify this. We're going to put this back into our p of x over q of x form. So we're going to have a common denominator. Treat it like when we have fractions. We've done things like this before. We want to put this back into our p of x over q of x form. So we need to have our common denominator. I was just going to say denom. I promise this is denom. No, I'm not denom. It's just smushed. Common denominator. So what do I need to multiply this 2 by to make it have a common denominator? X plus 3 over x plus 3. That's going to give us our common denominator. So our f of x is going to equal, we're forcing it to have that x plus 3 as a denominator. So we're going to have our 4 minus 2 times our x plus 3. I'm just going to write this in several steps so we can see it. So as we distribute that out, we're going to have our x plus 3 as our denominator. So we have 4 minus 2x minus 6, distributing our minus 2 through. So when we simplify that, what do we get? Minus 2 over x plus 3. So when we have it in this, that's a transformation form, which we'll get to eventually and what that looks like and how we can work with it as it is. But it's been a minute since we did that. I do recommend putting it back into our p of x over q of x at this point. So let's find our x-intercepts and y-intercepts. Our x-intercepts are going to happen when our numerator equals 0. So when does our numerator equal 0? Yeah. Minus 2x minus 2 equals 0 when x equals negative 1. Add 2 to both sides, divide by negative 2, we get negative 1. So our x-intercept is at the point negative 1 comma 0. What's up? What do you mean? We will, to find our y-intercepts. Substituting 0 into the x is when we get our y-intercept. Our x-intercept comes from when our numerator equals 0. So we're going to do both. So to get our y-intercept, that's when I take my whole function and we substitute in 0 for x's. I'm going to make this smaller. So I'm going to take the whole thing. I'm going to do it in purple. So we're going to have our minus 2 and substitute in 0. Minus 2 over 0 plus 3. This is how we get our y-intercept. Yeah, so negative 2 times 0 is 0. 0 minus 2 is negative 2. 0 plus 3 is positive 3. So our y-intercept happens at what point? 0, negative 2/3. Okay. So we'll be using x and y intercepts to help us plot points when we get to the point of graphing these.
Oh,
We're going to get to the point of graphing these, I believe tomorrow. Maybe Friday. Yes. There's a lot of things involved in these. Okay? We'll do one more thought for today, and then I'll get you guys the review for the quiz, so we have some time to work on it and ask questions and all that jazz. Quiz is on Friday, just so we're aware. I just want us to have time to work on it and ask questions, because this is one of those ones that is very scary. What's up? All right, so here we go to the point where this is one of the reasons why we want to write it in factored form. We're going to talk about our removable discontinuities. We've used these recently. Last chapter we talked about discontinuities. Yes, you do. It's when we factor and there's a common factor in between both of them. So when we have a function like this where we have f of x equals x squared minus 6x plus 8 over x squared plus 4x minus 12, what we're going to do is we're going to factor both. Factor our numerator, factor our denominator. I'm going to zoom this in. I'm going to let this be here for a second so you guys can write the words down. And then when it comes to the point of us calculating this, I'm going to zoom it in because I know the equation is very small for those of us in the back. Like I said, the words would be... For which one? You're right. So where's your discontinuity? But we're writing them as a point. So how do you find your y? Okay. So I'm going to zoom this in a little bit just because I know my equation's a little bit small, especially for those of us in the back. There we go. So here's our equation. We got f of x equals x squared minus 6x plus 8 over x squared plus 4x minus 12. We're going to factor both of these. So this is going to be the same thing as, what does our numerator factor to? X minus 2, x minus 4. What does our denominator factor to? X plus 6 and x minus 2. We good on that? All right, what do we notice about these two pieces? The x minus 2's are going to cancel out. And it's going to leave us with what? X minus 4 over x plus 6. So what is that x minus 2 telling us? We're going to have a discontinuity when our x minus 2 equals what? 0. So it happens when x equals 2. But that doesn't make it super easy to graph. X equals 2 is great, but that's a line, not a point. And a discontinuity, a removable discontinuity happens at a point. So it's not going to be 0. It is not going to be at the point 2, 0. Substituted in where? Our leftover bits. Substitute it into your leftover bits. So we're going to take our 2, and we're going to have 2 minus 4 over 2 plus 6. So we get negative 2 over 8, which simplifies down to be negative 1/4. So our y value is our negative 1/4. So our removable discontinuity happens at the point 2, negative 1/4. Okay. Where are we going to have x-intercept? Just to review the other things we did. Our x-intercept happens when what is 0? So the 2 we already know we have a problem with here. So if we have a discontinuity, it is not one of our x-intercepts. So it's just look at our leftover bits. Our positive 4. So our x-intercept is going to happen at, that's not a pen, 4, 0. Where is our y-intercept going to happen? Because it happens when x is 0. If x is 0, we have negative 4 over positive 6, which is the same thing as negative 2/3. Okay? Simplify it down. That'll make it easier when we get to the point of graphing those pieces. So we have 3 points about this whole function that we know. We could also find out our domain. It's every place except for where? Negative 6 and 2. We still have that discontinuity that affects our domain. So it still affects our domain. It's just not, we're not going to have them as an intercept. Okay, so tomorrow we'll get into what happens with our asymptotes when we're getting those going on. Because these graphs, when we're graphing them, this is when we have our like vertical asymptote and the horizontal asymptote, and they look kind of like these guys. These are the ones. This is what these look like. You've done them before. You're not. We'll get through it. I promise. What's up?
Y equals -1/4. Would it be -2?
It'd be -2 over 8. 2 plus 6. And so the -2 over 8 simplifies down to be -1 over 4. From the -2, that would be when we took this and we substituted in x equals 0. So 0 minus 4 over 0 plus 6. So just like on this one when we substituted in the 2, this one we're substituting in a 0. Okay, so that's where we get -4 over 6, which simplifies down to be our -2/3. Okay. So we'll talk more about asymptotes and what we do and how we can start working on graphing these tomorrow. I want to give you guys the chance to look at this and try this so that when we come in tomorrow, if we have questions, or if you want to come in during study time and have questions, we have time for that. So I'm going to put up the homework page, just saying. And then I'm going to give you guys the review for quiz 8. Quiz 8 comes up on Friday, but I'm giving you guys the review so that you guys can look at it and try things and practice some of this stuff, okay? So if you want to work on homeworks 1 through 4, or if you want to work on this, that is also fine. This is your time to do with what you need to. We're in a good place schedule-wise. There's the review. Okay?
We substitute these numbers into here.
You have a question I can help with?
I substituted these into here, right?
Okay. I was gonna be like, what section it is? Okay. Finding all solutions. So, yes, you're gonna be substituting in and see what the type of do. So we have a ±1, ±2, ±4, +8.
And it's until I get 0 equals 0.
Until we get a 0 on this side.
Oh,
Right.
I should write that 0.
Yeah. I mean, they have this equal 0. It doesn't really make that much of a difference in what we're doing, but our roots will have it equal 0. They've just worded things